thank you all very much for coming. My name is Alastair Smith. I work at Redgate Software in the UK in Cambridge. We do tools for Microsoft SQL Server developers and DBAs. I'd like to talk to you today about how to apply test-driven development to your database objects. I'm not here to sell you our tools as part of this talk. It's not a sales pitch at all. It's about applying the practices to your database as well as your application code. The demos that I've got are on Microsoft SQL Server 2014, but the concepts are applicable to any RDBMS as far as I've found. There's a really good site called testanything.org which has unit testing frameworks for Postgres, MySQL and Oracle as well. So you can try out the demos and what have you that I've put together on those systems too. Additionally, Oracle's own SQL Developer ID has a unit tests feature. I've not used it myself, but if you're familiar with that ID, you might want to take a look at it for some of these concepts. So, first of all, why bother testing your database objects? Well, the reasons are really very similar to the reasons that we test our application code. So we can get early bug notification about things that have gone wrong in our stored procedures, for example. It can give us confidence to refactor. So when you've got your 1,000-line stored procedure or whatever it is that you're working on, you can see what the behaviour is of that procedure and see where you can make the changes and be comfortable in doing so because you've got the test suite available to catch you if you make a mistake. And finally, the key one for me really is the concept of verifiable documentation. You get a green tick against every test when it passes saying that this particular aspect of the stored procedure is working correctly. It's executable specification, so you see exactly what the stored procedure has been designed to do, and a verification that it has actually performed that function. So, how does this work in practice? Well, as T.A.K.E likes to say, make it work, then make it right. So we follow the usual red-green refactor rhythm of test-driven development. We write just enough of a test to fail. And we use compilation failures as a red test when necessary, because if you haven't got a stored procedure yet that you're writing a test for, then the test is going to fail to compile, and that's the kind of indication that we need to introduce the procedure at all. We then run all of the tests, and we see that we get exactly one expected failure. That's the test that we've just written. If we have more than one failure, then we've already broken something, and we need to fix that before we move on. In the green stage, we write just enough code to pass the failing test, and no more. And that can be as simple as writing a return constant value statement or something like that. And we run all of the tests again, and we see that the one test that was failing now passes. Finally, we refactor the tests and the application code, and we remove duplication in this stage. Removing duplication is really the key driver for refactoring as far as I'm concerned. And we can also do your standard tidy up type tasks in this case as well. So sort of renaming variables, moving bits of code around, and as long as the tests all still pass, we know that everything is still working correctly. So we can apply this to our stored procedures and our functions as well using database unit testing frameworks. And the one that I'm going to demonstrate today is one called T.A.K.E. This is a unit testing framework for T-SQL, Microsoft's sort of dialect of SQL, and it's available for SourceForge. In spite of that, it's still under active development. T.A.K.E. runs each test in isolation, and it uses a separate SQL Server transaction to achieve that. And this is really common across all of the testing frameworks, including the test anything ones that I mentioned at the start of the talk. The key mechanism for isolation within a database is a transaction, so each test will be run in a separate transaction. Additionally, T-SQL-T groups tests within schemas, which is a Microsoft SQL Server sort of specific feature that allows you to partition your database into different concerns, essentially. And T-SQL-T uses schemas to represent test classes. So, for example, it's very similar to the concept of test fixtures from JUnit or NUnit or anything along those lines. And this gets you the same sorts of benefits. It allows you to group similar tests together, and it allows you to get shared. It allows you to share setup code across your tests. Something that I found when putting together the demos is that creating a test class in T-SQL-T will actually overwrite it if it already exists. This gives you yet more test isolation for each run, because it's like creating a new instance of your test fixture for each run of every test. Finally, T-SQL-T can also fake tables and views, and it can spy on the stored procedures as well. I'm not sure if this is something that applies to the other platforms as well, because this is a feature that relies on a specific feature of SQL Server, the SQL CLR, which allows you to run .NET code in your database processes. So it would need a bit more sort of investigation to see if a similar thing can be done with Oracle and what have you. So let's see how we can get started with T-SQL-T. So here we have Microsoft SQL Server Management Studio. This is the sort of standard tool for working with SQL Server databases. And you can see that we've got a database here called Chinook. Has anyone come across the Chinook database before? One person. Okay. It's a really good database for sort of modelling real-world scenarios. It models sort of music store. So you can see from the list of tables that we've got that it handles things like albums and artists, but also customers, employees of the music store, orders, etc., etc. So in order to set up T-SQL-T, let's just collapse that for a bit more space. We need to do two things. So the first thing that we need to do is to enable the SQL CLR for the database. As I mentioned before, this is a requirement of the faking and spying features of T-SQL-T. And it does actually come with some performance concerns, so don't enable this on your production database, because it will kind of slow things down. Also, I think Microsoft found a massive security hole in the SQL CLR just a month ago or so, probably best to just leave it off in production in general. So we've now turned on the SQL CLR, and we can then install T-SQL-T. So this is just the standard zip file download that we've got from SourceForge. You get both of these scripts, and you get a sort of example script as well to show off some of the features of T-SQL-T. So that's now installed, and we can see that from looking at the list of stored procedures that we now have available, you can see that we've got the T-SQL-T schema, and there's a whole bunch of functions, stored procedures that have been installed into that schema in the database. So there's assertion functions, we've got faking functions, etc., etc. So that is now T-SQL-T set up on the database. So we want to check that it works. So let's start a new script, and we will do that by first of all creating so we're going to start by creating a test class, so like a test fixture in Unit. We do that by executing the new test class function. and we're going to call that something very simple like does it work? And we execute that, and that's completed successfully. So our tests in T.A.K.E are just stored procedures that get saved into your database. So we can do that by saying create procedure, and we're going to add it to the test class that we just created. And test T.A.K.E works properly. So in T.A.K.E the test functions that you write all have to start with the word test, otherwise the framework won't find them. And we can say in here, create a table, or create a table called album.expected, which has an ID, we'll type int, this is the identity, has a title, which is of some size, oops, and it has an artist ID, which again is another int, and we're going to execute an assertion here. So insert results, let's have say metadata, expected command is select start from expected, and the actual command is select star from album. Okay. And so what this test is doing is it's creating a table of a particular shape, which is our expected table, and then this assertion essentially says, does the schema of the table match on the real one versus the expected one that I've created? The expected command is selecting star from album expected, and the actual is selecting star from dbo.album. We've just created that test, so if we were to refresh the Object Explorer here, then we'd see that in there, and we can now execute that test by saying T.run all of the tests. Okay, so we've already created that, but we can see here that the test passed correctly. So the two tables that we've got, the one in the actual database and the one in the one that we created as the sort of expectation in the test, is they have the same columns, they have the same types, etc. So that's a sort of very simple getting started example. Okay, so some recommendations of the types of things to test and perhaps not test. So the first thing that I'd say is do test your stored procedures, your functions, your triggers, your views, your constraints, maybe even your coding standards if you want. I'll come back to that a bit later on. However, don't test your object structure. The test that I just wrote is going to lead to very brittle tests. Anytime you change the shape of the table that you're testing, it's going to cause the test to break in exactly the same way, and it's not going to give you the kind of feedback and information that is really helpful. So on that basis, let's take a look at how to test some of the more useful types of objects. So we'll start with stored procedures. So as we're doing test-driven development in this talk, we'll start by writing our test. And the requirement that we've got is that we want to add a stored procedure for retrieving the album for a given artist, and that's by the artist name. So currently, if we look at the album table. Let's just bring up the results of that. So you can see that we've got an album ID, there's a bunch of titles, and there's an artist ID. But we want to be able to display that in a meaningful way to our users. So we want to say this album was released by this artist. So we know that there are 3 albums in our database by Guns N' Roses. These are Appetite for Destruction, Use Your Illusion 1, and Use Your Illusion 2. So we can use that information to power our tests. So we'll say use the Chinook database, and we will execute new test class again, because we're now creating a different set of tests, and this is some of our music tests. And we can create a stored procedure again for our test, which is artist by name, returns the reference for the given artist. So this is a fairly simple specification of what we expect the function, the stored procedure, to do. And the way this is going to work is we are going to say, so we're going to use the standard arrange act assert pattern for our unit tests, like so, and we can create a table for our actual results. The hash here just indicates that it's a temporary table. And this has a single field, which is the album title, which is a string of some length. And so we then insert into the actual temporary table. Into here, say execute. Am I standing on the code? It's back. Execute dbo.albums for artist by name. Artist name is. So this is the act step of the test. So what we're saying here is execute the stored procedure albums for artists by name, and insert the results of that into our temporary table that we created. Don't know why this is flicking on and off. And then for the assertion phase, we create another table which includes the expected result. So again, this needs to match. And this time we write hard-coded insert statements. So insert into the temporary table the 3 album titles that we know exist. And finally, we write our assertion where we want to say, are these 2 tables equal? So the expected table is simply expected, and the actual table is simply actual, and we don't create values. Okay, so that's our test function written, and we can now execute all of the tests again. Oops. To see if that works. Okay, so we've got an error here, and the error is that we could not find the stored procedure. So that's our compilation failure as our sort of first red phase. So we can now go ahead and create that. So we create a new stored procedure, and for the first implementation of this, so this is album for artist by name, which has a single parameter called artist name, which is a large 60. And then applying a sort of iterative development approach here, we can just say that we take the album title from album, and we can create that function and run the tests again. And you can see here that we've got a list of all of the album titles that were returned, and there's quite a nice sort of diff view that you get from T=T in this approach. So you can see the first 3 lines indicating that the two are equal in the 2 result sets, and then in the remaining ones it's that the actual result set has extra rows that the expected result set doesn't contain. So that tells us that we've got something extra that we need to do. The test has failed because there's more data than we were expecting. So we go back to our stored procedure, and we can then add in the remaining code to make the test pass. So we add an inner join from DBO artist to artist ID to the artist table, and we add the restriction as well. Oops. And we just need to change this to an alter statement, and we can run that again. And you can see that we've now got, but you can see now that we've got both tests passing. So we've successfully test-driven a stored procedure in a database, which is pretty cool. So the other demo that I wanted to give at this point was how to test your constraints as well. This is a little bit of a weird approach in some respects, because you need to test for the constraint failing. The constraint will apply by default, and we have to test for the failure of the constraint in order to see it doing anything, which leads to slightly odd tests, because we need to set up the scenario where the constraint won't apply, and then see the constraint fail and catch the error from the database in that process. So let's go through and do that. So we want to create another procedure. So within the database we've got the customer table, and and there is a constraint. Is it the other way around? Yes, here we go. We've got a constraint that the support rep ID for a particular customer must be an employee of the company, so it must be a valid ID in the employee table. And so the way that we go about this is we create a fake customer table that only has the constraint on it that we want, and then we use a try-catch to catch the error thrown by the constraint. So let's go through and put that together. So to create a new test class. And again, we follow the arrange, act, assert pattern. So in our arrange step, we first of all need to declare a flag, essentially, to state that whether or not the error was thrown, which we do by error thrown is a bit, and we initialize it to 0. We create a fake copy of the customer table. And we say we want to fake the customer table from the DBO schema, which is the default schema in SQL Server. And we want to apply the constraint that we are interested in to the fake table. So we go to the customer table and apply the foreign key constraint of customer support rep ID. Okay, so we've created our fake table here, and this statement copies the foreign key constraint from the real table to our fake table. So now for our act statement, try begin and catch. So we insert into DBO.customer, and we don't actually care about any of these values here, with the exception of the support rep ID, which has to be 0 in this because 0 is an invalid support rep ID in this test. So we do that insertion, and we end and say in catch and catch. I've got my syntax wrong here. And we say error thrown is 1. And finally, we want to fail our test if the error was not thrown. And the way that we do that is we say if error thrown is 0, then execute a failure function. And just delete all of this boilerplate and say insert succeeded. Okay, so we've created that test successfully, and then we can do the same again of running all the tests. So you can see that that test then passed. And just to sort of clarify the way the test is working, as I say, we create the fake table, we apply the constraint to our fake table, we then try to insert into our fake table, and because support rep ID, the value that we're inserting is 0, that's an invalid value for that foreign key constraint, so that will then cause the insertion to fail and throw an exception. We catch that exception here and set the error thrown flag to 1 to say that the error was thrown. And then if the error was not thrown, it still has its default value of 0. Then we fail the test explicitly with a message saying saying that the constraint was able to be violated. Okay, so that's how you can test your stored procedures and constraints. And you can apply the same sort of process to your functions, to your views, and all the other types of objects that you might want to be using in a database. So this is some C# code for creating a new customer object from a unit test that I just sort of put together. This is a fairly sort of standard unit test. We create an object, we create a couple of objects rather that have a bit of a relationship. But the main thing here is that the test actually doesn't really care about a lot of the data that is being set up here. We've got things like an address and a name, and maybe actually we only really care about the name in this. And so one of the techniques that we can apply to clean up this code is the test data builder panel. And that allows you to sort of rewrite your tests in this kind of format, where we set up the default data using a sort of factory method for the class, and then override specific parts of that object with the values that we really care about. And we can actually use the same approach in our database unit tests as well. So if we hop back to Management Studio, then this script. So the nice thing about SQL is that, or T-SQL at least, is that it supports optional arguments. So what we can do is create a procedure that allows us to build a row for the customer table in this example, and just populate the fields with the default values, and then override them in the usage when we actually sort of want to make use of it. So there's quite a bit of code here, and part of that is because of T-SQL-T. So the first block in this if statement here is it takes care of the state when we're using the real table within the database. So that has a sort of incrementing ID, and we can make use of the scope identity function then to identify which row was inserted in this state. However, if we're using a table that has been faked by T.T., then that table may not have the identity capability set on it. And so we need to generate a new ID for that insertion ourselves, which is what this line is doing here, creating a customer ID for it. And then we can use that. We can use that quite nicely. At the bottom here, you can say use the customer builder function and just insert the row with the first name Joe, and everything else will be initialized to the default values. And in the example that we've got here, we've got just the default values for the database table. So all the strings are initialized to the empty string, all the ints are initialized to 0, etc., etc. But you can set this up with whatever you want. If you want your default data to say the first name is Joe Blogs, because that's the majority of your cases, then you can absolutely do that here. Right, so that is test data builders. A couple of other examples. You could also do test data builder. So again, you can just override the specific values in the table that you want. Great. So, so that's our SQL test data builders. I mentioned before that you could do naming conventions and code standards and that sort of thing as well with tests. For SQL Server, there's a product called SQL COP. Again, it's an open source thing that you can use. I don't know whether there are equivalents for Oracle and what have you, but I would imagine that there is some way of achieving the same the same objectives. So what SQL COP allows you to do is to verify that your naming conventions all match, check for missing foreign keys, any fragmented indexes, check that the database collation is correct, etc., and so much more. There's a quick look at this. So we can add, that's a new test. We can add our Chinook database to SQL Test. SQL Test is one of Redgate's products. It just allows you to hook up T.T. and SQL COP very quickly to the database and run the tests in a sort of nice way. So we can just right-click on the database here and add the SQL COP tests to the database, which we've now done. And you can see that we've got a whole load of tests that we could execute against this. And some of these are for code standard examples, so things like naming conventions. So got procedures named SP underscore. This used to be a convention within the sort of SQL Server community and is now being kind of moved away from because it's Hungarian notation. Not something we really want in our code. There's a couple of other things as well. So it will also check for production concerns as well. So things like XP command shell. This allows you to call out to any process on the system, which you probably want turned off in production because executing arbitrary code is bad. So yeah, it allows you to check for that kind of thing as well. And this is really useful for cases where you've got a sort of production-like environment. As I said before, Adding the SQL CLR to your production database will slow it down just because of what it does. So you probably don't want to be running these tests on production the same way you don't want to ship your unit tests with your application production code. So that's SQL cop. So we've written our unit tests. What about the continuous integration aspect? We want to run them automatically as part of our build. We want to ensure that they don't ever break. We want to be notified when they do break, etc. So there's a nice runner for T.A.K.E from a guy called Christian Prieto, and this is available on GitHub for download. And it just plugs directly into TeamCity for executing your T.A.K.E tests. We also have the aspect for the database that we don't have for application code, where we need to actually deploy the database in order to be able to test it. And we essentially need to go through all of the setup steps that I demonstrated by hand at the start of the talk on our continuous integration system as well. So let's look at how we can do that. So I've got a TeamCity instance set up here. Sorry, I think it's still warming up. And if we go down to the build steps, we can. Well, let's edit this. Cool. So the first thing that we have to do, as I said, is to deploy the database. The way that we do this is using a custom SQL script. Custom command line script and the SQL CMD tool to execute our SQL script. So the script that we've got, it calls SQL CMD against our local server. It enables quoted identifiers. That's the square brackets in the SQL syntax. And we execute the SQL script to create the database in the first place. That's this one here. So that's deployed the database, but then we need to do things like configuring the SQL CLR and installing T.A.K.E, as I mentioned before. So again, we do exactly the same thing. We call SQL CMD on the local server, and we execute the set CLR enabled SQL script and the T.A.K.E installation script. These are exactly the same scripts that I showed you earlier, checked into the source control Git repository. And finally, we need to deploy our custom objects as well. So these are the tests that we've created, the stored procedures that we've created, that are in addition to the sort of baseline of the database that's created by the installation script. So we've got the albums by artist name stored procedure, and we've got the tests for that stored procedure, and we've got the tests for the constraint as well, the foreign key constraint. So at the end of this step, we've got the database in exactly the state that we need in order to be able to execute it. We can then call the T.A.K.E runner that I said is available on GitHub for download, and we just run the tests. And this is very nice and simple to configure. You just pass it the database server name, the database name that you want to find the tests in and run, plus any extra sort of authentication information, etc. that you need. And finally, we want to clean up afterwards, so we drop the database. And the way that we do that is using a bit of hard-coded SQL here, and that just does a couple of checks and then says drop the database, we're done with it. And if we run that, oh dear. Ah, yes, it's downloading. I don't have a network connection on the VM, sadly, so we'll use a previous run of the test for the demo instead. So the nice thing about this particular test runner for T-SQL is that it plugs directly into TeamCity's own test reporting mechanism. It reports the test results in the same format as NUnit, so TeamCity can then display it in its usual kind of nice way. So you can see that the two tests that we wrote have passed. The screen comes back. And we can also look at the build log and see that we've got this is just the end of it, but these are all the sort of steps to create the database in the first place. We configure the SQL CLR, install T-SQL-T, we go through the deployment, run the tests, all of the tests, and we drop the database at the end as well. And the whole thing takes not very long at all for a sort of fairly simple set of changes. What is it? 17 seconds to go full round trip. So that's not too bad. Okay. So that's all of the demos that I've got for today. I don't want to keep you from lunch, but if there are any questions that you've got, then feel free to ask. Otherwise, thank you for listening.